walk us through the comments and questions? This is Gary Ellert from GPH.
Sure, Gina.
Thank you.
Starting with slide 2, the first NRC question was on the RCCV report, and that was WG3-T11-DRD-S-0001, and it was a request to indicate that the method used, or a question I should say, on the method using thermal ratios evaluated by 3D nonlinear analysis applied in the standard design is not used for NA3, and the effects of concrete cracking due to thermal load are considered by reducing the thermal stress in SSDP-2D. And going into the specific questions, is this change in the method of calculating thermal stresses considered a departure from the method used in the standard design? And the applicant is requested to explain why this change is acceptable, and during the audit too, the staff requests a detailed presentation of the methodology. And also the question was, are the design thermal loads considered the same as the DCD thermal loads? Going on to page 3, first is a question on the methodology, and the use of SSDP2D is identified in the departures report as a difference from the DCD evaluation for the RCCV thermal loads. The use of SSDP for addressing thermal loads in the NA3 RCCV structural evaluation is described in both in the FSAR 3G752. I don't think I need to read what's up there, but you can see that. It's also in the COLA Part 7, NAPS DP 3.7-1 departure. Going on to slide 4, explaining why this change is acceptable, and basically the DCD RCCV report thermal loads for the structure evaluation were evaluated by thermal ratios and SSDP-2D methods. Basically both methods were used. The DCD RCCV structure evaluation report explains and compares the two methods. One is what the so-called knockdown factors, which came from the 3D nonlinear anal method, and then there were reduction factors coming out of SSDP-2D. Going on to the next slide.
Before do you use the both method for standard plant? Like first you knock down the ratio, the stresses or whatever, and then use...
Not at the same load combination. The for RCCV design, as described in 3G1 of the DCD, the knockdown nonlinear analysis knockdown factors was used for loca thermal cases, and we use SSDP-2D for I will call environmental thermal cases, non-loca.
Okay, so it is in a two different situation.
Yes, but
load combination.
Hold on, let me continue the explanation. It might answer some of your other questions. During the DCD time frame, though, we made some design changes in the upper pool, and these are described and these are thermal changes to thermal, and these are described in Appendix 3G.5 of the DCD. For that reevaluation of the RCCV top slab and the upper pool structures, we used SSDP-2D for those local analyses. So the method was used in both. Basically, both methods were used for loca. We also have. I should be in the slides, but there was a DCD REI where the NRC, we compared the two methods, and the NRC approved and wrote it up in their FSAR the approval of both methods. I believe that's discussed on page 5 of the slide as REI 3.8-107, and in the DCD FSAR section 3.8.1.3.4.
Okay, my question is not much of, basically we are departing from DCD approach. The question is, if this SSDP method is as conservative or more than whatever the thermal ratio method, then why are you taking these departures?
Going back to the DCD time frame, the original analysis that was done in 3G.1 or described in 3G.1 of the DCD was based on a top slab concrete strength of 5,000 psi and a certain thermal loading. The stress ratios were very, very high for 5,000 psi concrete. When we evaluated the additional thermal cases that were evaluated in 3G.5, we found overstresses, and we changed the concrete strength from 5,000 to 6,000 psi, along with the rearrangement of the structure a little bit, and reevaluated under 3G.5. Going back to 3G.1, we end up using the nonlinear knockdown factors to reduce the conservatism in order to make the original 5,000 psi concrete top slab work. The SSDP was just too conservative. When we went to 3G.5 with the increased concrete strength, we could make it work with the more conservative SSDP-2D method. And so we stuck in, both to save time and cost, we went with that method for the reevaluation that's described in 3G.5.
So the bottom line is SSDP-2D is still more conservative than the other method.
Correct.
Okay.
I have a question. This is Sonopha. On slide 3, the third bullet, okay, there is a second third bullet which is about the COLA Part 7. There, within the quotation, there's a statement saying the thermal loads for the RCCD are reduced using the SSDP-2D process. Now you are talking about SSDP-2D leads to conservative results. Now here you're saying the thermal loads are reduced with using the SSDP-2D.
No. Thermal loads are not reduced. The thermal stresses, because we increased concrete from 5,000 and 6,000, are reduced. We have higher strength concrete, so we get the allowable goes up, and so the original concrete stress now is okay. I mean, would have been an overstress under 5,000 psi concrete.
Okay, so you're talking about the stresses in concrete and the rebar. They
compared to the allowable stresses in rebar, not the thermal load, i.e. forces or moment resulting from the thermal. That's a different aspect.
Yeah, if that's the case, I think that since the sentence agrees that way, the reader may get confused. I don't know if you want to go back and consider revising it, or
we can check it while we do the audit.
Yeah, we'll say we can do it during the audit, and if we need to revise it, we can.
This is Gerald Braverman from B&L. I think, in summary, what's lacking maybe is an explanation why you reverted back to the supposedly more conservative SSDP method. And we're hearing, I think...
Well, I could do that.
Yeah, I think we're hearing now for the first time the reason you could do that is because you changed the compressive strength of concrete. So I think it'd be useful, and not just to hear verbally, maybe put that in the FSAR or some documented information source. Okay?
Okay. We can take that under evaluation. That's no problem. Just to reiterate why we switched, excuse me, Gina.
Yeah, what I was
whoever
saying
was talking.
is you're taking a departure, so that draws the staff's attention, so I think it's useful to explain why. The other thing is you could have still used the same method as the DCD without a departure, but let me ask, you saying that would save you time and cost. I'd like to understand that. You would have used the same thermal ratios, wouldn't you? And therefore, you could still use the SSDP and scale it down, or would the thermal ratios change?
Let me back up a minute. I don't think I want to talk about the DCD results because that's done and sealed. But anyway, for the FSAR effort, we had the same thermal, which is you're going to slide 6. Basically, the thermal inputs to the analysis, i.e. the surface temperatures, initial surface temperature, temperature profile, and everything used in the evaluation is identical between NA3 and the DCD. There's no changes in basically the design basis thermal input. What we did, if we're looking at the reevaluation effort, in order to calculate nonlinear knockdown factors based on for the upper pool area that we did not do during the DCD, I should say, excuse me. We would have to repeat the knockdown factors using the revised model and recalculate, and that would have been I'll call it 3 to 6 month effort.
Oh, you saying the model would have changed because of
the knockdown factor, the nonlinear model would have changed.
Because of why? The strength and any other changes?
Because of the changes in the DCD since, remember, the knockdown factors were calculated based on the model at the time that 3G1 was developed. When we wrote 3G5 of the DCD, we revised the model.
Oh, okay.
We did not go back and redo the knockdown factors.
Okay, that explains it.
I think this explanation would be helpful in some fashion.
Okay, I would just like to point you to where we do discuss this in the FSAR in 3G.7.5.2, and also in Part 7, we have a large paragraph that discusses this overall change to evaluate the upper pool. So it is included. I think we could discuss if there is something that we need to modify, but it is already included in the FSAR and in Part 7.
What I don't remember, what's written there, it probably describes what was done. My question now is, does it explain why you departed from the DCD method?
Yeah, that part is
I think that may be missing.
I got the explanation, which is basically revised model that you have to rerun, which is okay,
Yeah, that's fine.
If that's the reason, fine, as long as SSDP2, is conservative and you have great...
I think that was implied in the write-up, but we can easily discuss it during Audit 2 and revise the words.
Yeah.
Add words, but that's no problem.
Right, so please look at that section and then we'll look at it as well. It does talk about the changes in the model.
We'll have to read it.
Okay.
Okay, all right, thank you.
Thank you, Patricia.
Okay.
I think I've already covered slide 6 in my discussion, so going to slide 7 is the actions. The first action is to better clarify the basis of justification. We're updating the WG3T11 report to better explain things in there. Then we're also we might need to change the second bullet, Patricia. The no additional action is required regarding a presentation during Audit 2. We basically feel we don't need to do a presentation now.
No, yeah, if you explain, you did.
We can have further discussion on added words. That's not an issue. That's not a presentation. I don't call it, but we can have that discussion during the audit.
Yeah, we can.
And we'll track this action with a 601 action here.
Hey, Gary, this is Skip. What I did here on the proposed action, where we say clarify basis and justification, I think we need to add the word reason, because I've heard the staff request reason several times, so that seems...
That's no problem. Yeah, go ahead. Yeah, I have no problem with that.
But let me clarify. I think it's acceptable what you're doing because it's the more conservative approach. But what's still lacking is why you're taking this departure.
The reason is they had a model with the ratio, which was an old model, and we needed that because it is not 6,000 psi concrete or something like that. And now that we have 6,000 psi concrete, we can take more conservative analysis without doing that repetition of the model.
Right.
That's all but it would be nice to have all these write-ups so that basis is clear.
No, we can take that up. We could discuss it further in the audit, and we can come up with a revised paragraph to put into the FOCR in Part 7. That's no problem.
Yeah, I think in your proposed action, you mentioned you're going to revise also the technical report, so that would be a good place to add that. Yeah.
Well, I think it's already adding that to the technical report. It's just now we just need to transfer it to the FSR into Part 7.
Okay.
Gary, this is...
Basically, that's where I was directed. Yes, Gina.
I think what I'd like to do is before the audit, I'd like to try to develop some words to propose to put in the FSAR if you think and if it's already in the technical report, then that's fine. We can show the staff the information there then, but hopefully we can try to make the FSAR changes before the audit. Yeah.
Yeah, we should be able to do that.
Okay. That'd be great. Thank you.
By the way, it says the TR will be revised to capture this.
Yeah, this is Skip. I really think we're getting a little off track here. I think the right path is what we said. We'll get the words in the technical report, review them during the audit, and then if some of those words need to get in the FSAR, we will. But I don't think anybody... Taylor doesn't agree that anything in the FSAR needs to be changed at this point. So, and I think that's what Patricia's saying too. So I think we need to stick with what we said. We'll add some more explanation in the technical report, review it during the audit, and then maybe or maybe not there'll be some words that have to be added to the FSAR.
Skip, I think we can talk about this after the call, okay?
Okay.
Any more questions on question 1?
Before moving on to question 2, I have a question on slide 6. The NRC sub-question was, are the design thermal load is considered the same as the DCD thermal load? And Dominion response is that NA3 and the DCD design basis temperatures are the same. Now, my understanding, just to correct me if I'm wrong, the temperatures are the same as a boundary condition, but the thermal loads are different in that the NA3 thermal loads are reduced using SSDP, which is also mentioned.
That's separate from the thermal load. You do your 2D or 3D thermal transient analysis, and the heat transfers into the concrete, and you end up getting a...
What the question I asked is whether you have the same, like surface temperature, and these are all same, and these are...
Yeah, they're all the same. They're all the same.
I wanted to verify, and they say that they're uniform, right?
Yeah, there's been no change in the thermal conditions. And the only way the internal temperatures of the concrete, for instance, would change is if the...
You reduce that temperature for the heat transfer calculation, to find internal...
No, we did not need to repeat the heat transfer calculations identical.
They don't have to, because they're the same thing. Gradients are same, average temperature is same,
so we are talking about thermal conditions or boundary conditions.
The only change was the knockdown factors and due to the cracking of the concrete. And that was only in the reduction of the moments used in the stress analysis. It has no bearing on the heat transfer analysis, or no effect, I should say, on the heat transfer analysis that was done earlier. Basically, the DCD heat transfer analysis was used as design input for the structural evaluation.
All right, thank you.
So go to the next question.
Question 2. Assuming no more questions, 1. Okay, going to slide 8. Question 2. Local models were developed for GDCS pool stress analysis, and referring to WG3 T12-ERD-S0001, internal structural design report, and the seismic loads are valued using spectral analysis. Question 1 was, are these models the same as the DCD model? Question 2, please describe the method used. And 3 is the lateral seismic pressure load on the pool walls due to the water, basically, is evaluated. Sorry for going that through quickly, but we repeat each question on each of the following slides. Question 1, are these models the same as the DCD model? And the answer is yes, they're identical. You can look, GDS pool structural models shown in figure 417 through 19 of the report are the same as the models used for the DCD. If you wish, during the audit, we could show you the DCD report with the exact same models and frequencies. Please describe the spectral analysis method and explain any differences between the DCD, the site-specific model in this regard. And is this method discussed in the FSCR? The basic question is the same method was used for both NA3 and DCD. The method used is a static coefficient method described in DCD section 37213. Going to question 3 is a lateral seismic pressure.
1 second.
Sure.
The phrase you use in the, I guess, or the technical report, you call it spectral analysis method, and in your response you refer to static coefficient method. It's kind of confusing. Most people would interpret when you say spectral analysis method, it's response spectrum method of analysis. So,
yeah, but the analysis is, I would agree there might be some confusion there, but the report does go through the method in detail of what's in the report, and basically what you're seeing in the report is the static coefficient method.
Okay, Mandis, maybe you can help me. I haven't looked at that report yet. Does it really go beyond simply stating the spectral analysis method was used? Does it discuss static coefficient method in the report? I thought not.
Well, I don't remember, but at any rate, in the report it says, spectral analysis. Now, you don't find spectral analysis in anywhere in the FSIR or DCD, the way the coefficient method.
You got to remember the report author, number 1 is Japanese, so there may be some language issues here, but
all I'm saying is
we can work that out later. But if you look at the analysis method, what they did was they calculated the frequencies of the GDS pool structure.
I understand.
They went through, found the spectral value of that times 1.5 per the static coefficient method and applied the inertial load of that acceleration to the structure.
Yes, and that's okay, and DCD has that method, okay? So,
and that report basically walks through that same method.
No, I don't.
It introduces, even though they describe, but it just says it's a spectral method, and nowhere in the FSAR we say that.
It doesn't use, well, anyway. We can revise this report to get rid of the word spectral if you wish, but that's the method used was the static coefficient method, and the method described in the report is the static coefficient method.
That's okay. I think what we will do during our audit is basically see that application of that method.
Yeah, but aside from that, I would like the technical report to be consistent. Could Dominion please go back and make sure that only the static coefficient method is described in the report, not the spectral analysis method, because it does lead to confusion. Do you follow?
Yeah.
I follow.
Just mention according to DCD, spectral method, coefficient method was used.
Okay. No problem.
Thanks.
And the third question, we didn't get the answer really. Is the lateral seismic pressure load on the pool wall?
That's the next page, which we got held up here. So if we can keep going.
Okay.
I'm sorry, interrupting you. Going to slide 10 on is the lateral seismic pressure load on the pool wall due to vertical pressure on the pool wall, blah, blah, blah. And the NA3 hydrodynamic pressures on the GDCS pool structure walls are determined using the same methodology as used for the DCD. And the NA3 seismic hydrodynamic pressures on the GDCS pool structural walls was actually determined to be less than the DCD seismic hydrodynamic pressures because of the low frequency response in the NA3 input motion. And hence the higher DCD seismic hydrodynamic pressures were used in determining the overall stresses for the NA3 site-specific evaluation.
Okay. We will review it and make sure that also includes the vertical component. That's all.
No problem. Both reports will be available for review when you're...
Could we ask Dominion, do they know the answer to this NRC question? Was the vertical component of the pool water considered in horizontal pressure?
Yes.
It was considered?
The methodology DCD and all meet the current regulations on, and the vertical seismic was in there.
Okay.
Both analyses.
Okay, no, because your response indicates you use the same method, and I don't question that you use the same method as DCD. I'm questioning, was the vertical component included when calculating horizontal pressure? Do you recollect that?
Yes, it was.
Okay, thank you.
Any more questions on 2?
I don't. Anybody else?
The actions is basically we have no actions identified. We'll have the reports available for the audit, but that's not really an action.
I think we said we need to make sure that the reports don't mention the spectral analysis method.
All right. At least the report makes coefficient.
We can do a markup on the report and take care of that. That's true, Skip. Thank you for reminding me. I don't think DCD mentions either of these at this level of detail, by the way.
DCD has described how
the methodology, yes. The static coefficient methodology is described, but there is no discussion on the GDCS pool analysis methodology in the DCD or FSAR, to my knowledge.
Yeah, in the GDCS.
It says it was analyzed.
Right. But for this, we use that methodology. That's fine.
Looking at the GDCS full report as well, and I guess the Dominion used the term spectral analysis method was because in the report there was the different modes, frequencies, and the border shape. They were presented in the report, although the only first mode was used, but there are subsequent modes in the report, and Dominion decided to use static coefficient method, even though Dominion conducted spectral analysis of GDCS4. So I was just, wondering. I was just guessing that the spectral analysis method is there because of that. But that is just my comment. But again, since the static coefficient method is used for the method to calculate the pressure, I think
the static coefficient guys. I'm sorry to interrupt, but the static coefficient method was to determine the inertial loads of the structure itself due to seismic motion at its base. The spectra itself and the frequencies of the water were used to determine the pressures on the walls in accordance to I forgot the exact specific guide, but it's...
Right, we'll look at it during audit too, so that's... But it appears to be the confusion here. Okay. The method itself is straightforward. That's just in the DCD, yeah. Right, and you use the dominant mode response, and then you account for,